Hi, my name is Stefano Sandrini. I'm a senior manager in the solutions architecture team at Amazon Web Services based in Milan, Italy. Today, I'm going to show you how to build a real-time multiplayer gaming application with AWS Amplify and AWS AppSync. Let's jump into my slides. First, we'll have a quick intro on AWS Amplify and AWS AppSync and how we can use them to build our game application. Then we'll have the demo part. We will highlight some of the steps to take to build the app itself. And then at the end, we'll have a Q&A session. But first of all, let's take a look at what is the gaming app that we'll build in this session. We have a web application that provides you the ability to create a game and become the host of a game. Other players can also see the list of available games and have the ability to join a game and start a one-on-one session. The game is a classic turn-based game, tic-tac-toe. It's played online and in real time. When it's their turn, players can place their X's and O's, and in real time, both clients will be updated with the new status of the turn and the new status of the game board. We'll use Amplify and AppSync to build this game. So what Amplify is exactly? Amplify is a set of tools and services to accelerate the development of a web and a mobile application. You can use it to build your application by configuring AWS backends fast and create and connect front ends to those backends. You can also use it to ship your application by deploying your application front end and backend. And then you can also extend your application with more complex deployment scenario using CDK. If you want to build an application with AWS Amplify, you can leverage categories to implement common use cases and common features of a modern application. Every category is backed by one or more AWS services, and today we'll be using three categories: authentication, data store, and API. When you ask Amplify to add the authentication category, the feature will be based on a service named Amazon Cognito. Amazon Cognito provides you a secure and scalable user directory with wide enterprise and social identity federation support and standards-based authentication. It also provides an optional multi-factor authentication. We also use the API category and will leverage a GraphQL API provided by AppSync. AWS AppSync is a fully managed GraphQL service with real-time data synchronization and offline programming features. If you are a front-end developer, it gives you the ability to query multiple databases, microservices, and even other APIs from a single GraphQL endpoint with a single request. Today, we'll leverage the integration between AppSync and Amplify in the demo. Also, we're going to use Data Store to manage real-time data for our gaming application. Data Store provides a programming model for using shared and distributed data without writing additional code for both real-time and offline scenarios. It makes working with distributed and cross-user data as simple as working with local-only data. It also is powered by AWS AppSync and DynamoDB behind the scenes. So this is the architecture that will be implemented and deployed by using those three categories. We have a web client based on React that leverages Data Store and its synchronization engine to automatically sync the local storage in your browser with the data we have in the cloud stored in DynamoDB. In order to do that, Data Store manages for you the integration with the API provided by AWS AppSync, leveraging GraphQL operations such as query, mutations, and subscriptions. And all operation will be protected using the authorization integration between Amazon Cognito and AWS AppSync. Now it's time for the demo. What are we going to learn in the demo? We learn how to rapidly build a full stack web application powered by AWS, how to deploy that serverless application, and how to connect your front end to a sophisticated backend using a GraphQL API. And also, we will utilize real-time user data for implementing the actual business logic of the game, scores updates, and leaderboards updates. Now it's demo time. The demo is a video. I've only edited the video to delete deployment time and the time to write the code, just to fit the time allocated for this session. So we start our demo in the Amplify page. In the AWS console, you see we already have other apps. And if we click the New App button, we can then build a new app. And Amplify will set up the backend environment and the Amplify Studio environment. So let's do that. We can name our application, and then the Amplify Studio setup will start. Amplify Studio is basically a visual web interface that you can use to easily build and ship your web or mobile application with no cloud or AWS expertise required. You see, we have a Launch Studio button. Now we can land into the Amplify Studio main page, and you see in the header, there is a staging label, and if you click the staging label, we have a list of environments. Currently, we have only the staging environments, but we can have multiple environments, such as production or test. Let's enable the first feature, which is the authentication. You see that we have configured the login mechanism as an email, already as a default. You can change it, but we'll leave email. You can configure sign-up features, for example, password settings, number of charts, including lowercase or uppercase characters or symbols. We can also change or edit the verification message. So it's basically a template of an email that Amplify will send automatically to our new accounts to verify their email address. So we can basically change this template, and then what we can do, we can hit deploy. And when we hit deploy, Amplify will start deploying authentication resources for us automatically. It uses infrastructure as code mechanism behind the scenes to provide Amazon Cognito resources. You see, Amazon Cognito is named in the label you see now. After the deployment, Amplify provides us a command for the command line interface that we can use to keep our backends and frontends in sync. So let's switch to our IDE and create a new front-end application. We're gonna create a new React app. So let's create a React app. It's gonna be a plain React application. So if we run the npm start command and we preview the running application in Cloud9, you see it's the standard default template of a plain React application. So now what we can do, we can use this command to keep our front end in sync with our backend managed by Amplify. You see, it's called Amplify Pool. It provides the app ID that we just created and also the environment names. So we can change environments if we want. We keep it in sync with the staging environment, and Amplify will start downloading configuration and identify that it is a React application and it needs to download configuration, currently just for the authentication that we just created. So now it's time to change our front-end application, creating some components for our game. So the first component is the board. The board is basically a matrix 3x3, and it's a matrix of boxes. So we can create a box component, and the box component is basically a button that we can click. And based on the player, the button will display X's or O's. Then what we can do, we can create a header. And currently the header basically will display only the title of the game, but in the future, we'll use the header also to display user information, such as the name of or email of the login user. Then we can create the game business logic. And the game business logic, it's inside a component called game.js. It contains the game board, as you see, as a matrix. It contains variables, and it contains the logic to handle input, so for placing X's and O's, and the game logic to manage the turn, and to verify if a game is won by the host player or the opponent player. It also contains some logic to display other components, such as some messages and stuff. We changed the default template to show our game component, and then if we run the npm start command again, we should see the new game in our application. So let's preview the running application, and as you can see, we have a header, and also we have a game board, and if we hit boxes, we have X's and O's. It's a draw, so also the game business logic works fine. Now, what we can do is we created the authentication mechanism so we can import the Amplify UI React libraries. It provides these with authenticator component, and if we wrap the entire application with this with authenticator component, the result is that the application is protected through authentication. Because we just did that, let's also create a sign out button, because now sign in is mandatory. So we also need to provide the ability to sign out to our user. And we place the sign out button in our header. Now that we created the authentication, let's start again the server. And now if we preview the application, you see that we have a login form. We didn't write any code for the login form. This form is provided by the with authentication component provided by Amplify itself. And the form is built out of the configuration we created in the cloud. If you remember, we had email as a default login mechanism. The component provides also a create account form, so we can create an account, provides password, confirm password. Amplify will send us the confirmation code based on the template we edited before. If we enter the confirmation code, now we are in again, and we see also the name of the logged in user. I think we can create also a second account, so then we can simulate a one-on-one session. So let's create a second account with my other email at amazon.com. Again, we must insert the confirmation code provided by Amplify. And if we confirm, now we are logged in with the secondary account. Now that we have authentication set up and running, what we can do, we can add hosting. So we can host our web application in the cloud through Amplify hosting. We can choose between continuous deployment or manual deployment. We pick manual deployment, so we can manually deploy our updates to our front end through this command, amplify publish, to publish our updates. When the publish is finished, Amplify provides us a public URL. If we access the public URL, you see the login form running in the cloud. If we log in, now we have our application running in the cloud hosted by Amplify hosting. Now, let's go back to Amplify Studio so we can start building our data model in the cloud. And the first data model we're going to create is the game model. So let's hit the Create Data Model button and add a model. The model name is Game. We can add some fields, for example, the host ID, so the ID of the player that creates the game, type string. We have multiple types. The opponent ID is a string as well. We will store in the cloud the status of the board. The board definitely not a string, not an integer, not a float. It's a more complex type. For example, AWS JSON, which is basically a string, but it basically contains a JSON. So we can pick AWS JSON as a type for board. We can add other fields such as the turn, and we can add the result. The result is actually an enumeration, so we can create an enumeration. Let's call it game result. It provides three optional value: draw, won by the host, or won by the opponent. These are the three game results possible. We will also specify that the host ID is required, so you can't create a game that is not hosted by anyone. Now what we can do, we can change the authorization mode. So we can provide authorization rule to our game model. We change it to Cognito user pool. We deploy the authentication feature based on Cognito, And then we can specify authorization rule to the game model. Any signed-in users can perform operations such as create, read, and update. You also see that Amplify Studio provides you a preview of the GraphQL schema that Amplify creates for you. You don't have to write it. You don't have to learn GraphQL schema. Amplify Studio will do it for you. We can hit deploy, and now Amplify Studio will deploy a GraphQL API based on AppSync, a DynamoDB table, and also provides us code generated for multiple language that leverage data store. So we can use data store feature to keep in sync our front end local storage with the data we have in the backend in real time and potentially also offline. So we can use these snippets to copy paste those snippets in our front end project, right? So what we can do now is we can pull our new configuration again with the same command amplify pull provided by Amplify Studio. Now you see that we have a new category API and also Amplify downloaded models that we can use to start querying data. So what we can do, we can create a component to show the list of available games. How we can get those available games? Well, we can fetch those games through data store and the models provided by data store automatically. We didn't write anything about that. The only thing we have to write based on the snippets provided by Amplify is the fetch operation. We can query all games that doesn't have any result. Also, we can observe changes to the game model. So anytime a game is created or updated, we can update in real time our user interface accordingly. So for example, if a user creates a game, we will save a new game, we will receive the message that a new game has been created, and we can add that game to the list of available games. Same thing for joining a game. We will update the game with the opponent ID that joined the game, and then we can update the UI accordingly. The same pattern and concept can be applied to the business logic. So we can create a fetch game to get the real-time status of the game board, for example, for the specific game ID. And then we can observe and subscribe to changes to that specific game. So anytime the game board, for example, is updated, we can fetch the new status. And anytime we have a new input, so an X or a no, we can update the game itself in the cloud, and automatically all clients will receive updates with the new status of the board and the new status of the turn. So let's publish this new version in the front end, and let's test it using two browsers with two different users. So the left users create a game, the right user in real time received the notification, and now you see we have a game that can be joined. We can join the game, so let's start playing. And as you can see, we have in real time updates from the left browser to the right browser. Axis, O's, axis, O's. This real-time UI refresh is basically based on data store. We receive the notification that the game is changed, and we just update the UI accordingly. Again, the business logic works. It's a draw once again, but we just see how in real time we can create an online multiplayer game based on turn, and in real time update the UI. Now, game is working. The last part is about creating a leaderboard with scores, for example, like assigning 3 points for a victory and 1 point for a draw. So let's create a new model called leaderboard. We are going to have multiple fields. We're going to have the score, which is basically a total score of type integer. Number of games played, again, that's an integer. And then we have the game streak. So basically a string that provides how many games we won in a row, for example. We also provide the player ID, which is required. You see there's also an add relationship button. We are not going to use a relationship for the sake of this demo, but potentially you can add a relationship with a different model that is basically the player. We're going to deploy again this new configuration. again through Amplify Studio, basically new models and new operations. So now we can select the leaderboard model, and you see Amplify Studio provides us with new snippets: create, update, delete operations. Again, what we can do, we can pull this new configuration. We are downloading basically the new models. And if we publish changes for components such as leaderboards, then what we can do, we can play again some games. Now the host won the game. So if we click exit, we just created a component that is called leaderboard that in real time is updated. So you can create a real-time leaderboard that updates anytime a game is completed with a draw or a won. There is also a global leaderboard, so we can display the status of your player compared to all other players in the platform. So I hope you enjoyed the demo. We saw how to rapidly build a full stack web application powered by AWS. We saw how to deploy a serverless application. We saw how to connect our front end to a sophisticated backend using a GraphQL API with very little knowledge of how it works behind the scenes. We also saw how to utilize real-time user data for implementing the actual game business logic, how to implement business logic to handle inputs, updates, how to update scores, and global leaderboards. Thanks for attending this session. Once again, my name is Stefano Sandrini.